we here find out the mean deviation, then Suresh will observe a negative figure. To nullify the effect of negative, we'll square it. And when we square it, to neutralize it, neutralize the effect of square, we just put the under root. Sudhir, it's like very simple. Again, I'm explaining, Sudhir. Imagine you are having 200 rupees and I'm having 100 rupees. Okay? When I find out the difference, it could be negative. What should I do to nullify this effect? Let me just find out the square. But if I do the square of this quantity, I need to under root also. So square of 100, under root. So this is going to be, what is a 100 square? What is a 100 square? Tell me, Sudhir. Okay. And this is going to be, the square root of this is going to be this. Because why not modulus sign? No, not a modulus sign. Many times you can't, at least, it's not possible many times. We will use a square in the case of negative values. It's not justifiable straight away. If you use modulus sign, but again, the summation of modulus sign, mathematically, it's not justifiable, Sudhir. We need, why we are doing this standard deviation, and why we are doing this standard deviation, because we want a generalized figure. Okay, generalized figure of deviation from mean. That's why. I no need to because we have a Somaya. Why we are putting that sign here? Let me just tell you why we are doing that. It's applied even on the denominator. Even it's applied in the denominator also. Soumya, it's applied in the denominator also. And why we haven't squared the, because here we won't observe negative. When you count the numbers, oh sorry, what is n? Okay, Soumya, in case of sample, n is a sample points, total sample points, or the number of respondents in the sample, or number of people in the sample. Okay, number of people in sample. N is what? Number of people in population. Numbers cannot be negative. Can you see that -5 people are there in the sample, or -10 people are there in the population? Do you think functionally it's sensible? Here we won't observe any negative figures. We just simply need to count them. So why we square them out? There's no reason to square them out. I hope, Soumya, you understood what I'm saying. In mathematics, square of I equals to -1. It's a complex number equation. That's why we are not taking into the consideration. Okay, who is saying? Arinda, you said something. I couldn't understand your question. How can we find out the variance without Excel? Lina, तो ये क्या था? This was without Excel only. Manually, I did the calculation, Lina. Lina? This is what basically. It's a degrees of freedom, Tejas. You may ask me what is degrees of freedom. Normally, real life data set is like randomly assigned observation. 13, or let's say you are gathering the age. Let's say you are, you are gathering a sample information at, let's say, age of the person may be like randomly coming like this way. So when you at least start entering the data, the age figures may appear like this, may appear in this particular fashion, which are randomly distributed. Okay, so first person's age is 30, second person's age is 12, third person's age is 30, then 56. So these are the randomly, so what we can do is, let's consider, so how many numbers we do have right now? 1, 2, 3, 4, 5, 6, 7. 7. Okay, this is respondent 1, this is respondent 2, this is respondent 3, this is respondent 4, this is respondent 5, respondent 6, respondent 7. Imagine that you have prepared a hard copy of questionnaire. This is a hard copy of questionnaire. Okay, you have entered this data. That means you must have 7 hard copies of this, right? This is 1, this is 2, 3, 4, 5, 6, and 7. You must have 7 hard copies. Now, if you shuffle them, and let's say randomly, if you pick up 1, this is 30. Okay, and if you enter the data again, maybe this could be. If you shuffle the 7 field questionnaire, and if you enter the data again, maybe this is the pattern. Maybe I'm saying. Okay, so these are the random. So in statistics, we call the random variable. This is called random variable. Why it's called random variable? Because we randomly, let's say, so when we at least gather, when we have a stake of field questionnaire, randomly we can choose anything. We can choose anything without repetition. Without repetition, we can at least select one by one. The same is like, now remember one thing, 1 plus B plus C equals to, let's say A is 10, it's 12, and this is again, let's say 8. What is this? You just tell me. What is this? You just tell me. And tell me this also. Tell me this summation. Tejas, quickly, tell me this. 10 plus 12 plus 8. What is this? Who said 40? Tejas, you need to learn basic mathematics also. Let me just tell you. Okay, so this is called commutative law of addition. Let's say if you change the places of the values, if you interchange the places of the values, the final result or the resultant figure won't change. There is no effect on the resultant figure if you interchange or shuffle the numbers. Okay, now the same law is applicable here. If you, let's say, rewrite this in any way, the total of this won't change, and the average of this won't change. Even the standard deviation of it won't change. Agree with me? Yes or no? Now, let me just come back to this example. Now here randomly, you have 10, you have 3 figures. Tejas, select one randomly. Select one randomly. 10, 8 and 12. Select one randomly. Tejas. This is your first choice, Tejas. Second choice. Second choice. This is your second choice. This is left out. This cannot be your third choice. It cannot be your third choice. This is left out. Number of choices can be 2. Can be 2. As I said, if you interchange positions of the numbers, the resultant figure won't change, won't be affected. But how many choices you can have? If the numbers are 3, if 3 numbers are there, 8, 10 and 12, then you have a 2 choices. 2 times you can at least shuffle the numbers, okay? But the resultant value would be 30 only. The same way, if you have 7 people, okay, one by one, let's say you have 7 field questionnaire. If you shuffle them up and one by one, if you select them for the data entry without any repetition, then you may have 6 choices. Got this? So n minus 1 is what? Number of choices. N minus 1 is what? Number of choices. Sum of sample observation divided by number of choices. If sample observations are this 10, 12, 13, 14, 16, then you can rewrite them by many of the ways. How many ways you can rewrite them? These are the 5 numbers. 4 ways you can rewrite them. Because randomly you can. So in order to calculate, see, when people used to calculate manually, when people used to calculate manually, chalo, first let me just select this for the summation. Now let me just select this for the summation. Now let me just select this for the summation. This for the summation. I made 4 choices. Because 12, last one is by default. That's how n minus 1 is a degrees of freedom. I hope it is clear to you. But that cannot be applicable in, let's say, population, because population is like a bigger concept. It's like a very big concept. Now Bharat ka population is 121 crore. 121 crore minus 1 person is what? It's equivalent to 121 crore. Do you think that is going to affect your n? If you do n minus 1, that is very much equals to n only. रवि किरण, नंबर ऑफ चॉइसेस 5 कैसे बन सकती है रवि किरण? 5 चॉइसेस कैसे बन सकती है? यू जस्ट टेल मी. Ravi Kiran, this is the questionnaire, blue colored questionnaire. This is red colored questionnaire. This is, let's say, a green colored questionnaire. This is yellow colored questionnaire. And this is, let's say, multicolor questionnaire. Select one by one randomly. Sujan, it's okay. I followed census 2011. It's okay, Sujan. Now, Ravi, this may be your first choice. This may be your second choice. This may be your third choice. This may be your fourth choice. You can't say that yellow color is your fifth choice. Only 4 choices you can make. That's why n minus 1. N is 5 minus 1. 4 choices you can have. I guess this is enough, I guess. Now one more topic which is called range, interquartile range. Now range is also playing very important role. So what is range exactly? So range can be defined. So this is a standard deviation concept, as I said. Okay. Now we'll discuss about that. But before that, I would like to discuss about the range. So range is nothing but the difference between the largest and the smallest observation. Okay. Easy to compute. That will give you the idea about the spread. Let's say in let's say my population, let's say the smallest person is, let's say the youngest person is, let's say 3 months old kid. Okay. And the eldest person is, let's say 80 years old. Okay. So this way range can at least help us to at least understand the spread of the data, because in range you just focus on the extreme one and the smallest one, extreme smallest observation and extreme biggest observation. Okay. Now what is a quartile? Quartile is, as median can divide the entire distribution in, let's say 2 parts. The median kya karta tha? Used to divide the distribution into 2 parts. Quartile kya kar raha hai? 4 हिस्सों में divide करता है. Okay. So this is known as quartile 1, this is known as quartile 2, this is known as quartile 3, this is known as quartile 4. There's a formula of it. Okay, we'll study the formula of the quartile, which is just given in your book also. Okay, so this way quartile can divide the things into 4 different quartile. Now this is what the 25% of the data. How this division can take place. So division of the data normally take place like this way. So in the first quartile, we just try to make sure that the 55% of the data can be fit in. Let's say in the quartile 2, we just ensure that the more 25% data can be fit in as per the magnitude of the data observation. Okay, so this way the quartile concept is, there is one concept called percentile. For that, I'll at least let me just at least discuss one particular example how percentile can be. Now in your school days, let's say you are very much aware about this way of ranking. Let's say if you have secured some marks out of 100, let's say you can say that, okay, this is a first person. This person D has this person D's rank is 1. Person C's rank is 2. Person B's rank is 3rd, and person A's rank is 4th. This is a rank normally we used to get based on our overall result during our school days. But let's say in our school days, the normal size of the class can be 70, can be 80, can be 100, not more than 100. Okay. Well, it may be, in the worst case, it can be, let's say 400. Okay. It's not at all possible, but still we can at least go with that. So this is, let's say, still countable numbers. You can assign the ranks from 1 to, let's say 70. 1 to 80, 1 to 100. It's like very much possible. But when, if you imagine examinations like CAT, where the students are in the lakhs, and let's say, how can we at least rank them? If we want to rank them, okay, what is the measure? If we want to rank them, the percentile is a measure. Percentile is a measure. Let's say I've secured 89.00 percentile. That means 89% people. Let's say in the CAT, 2019, let's say 5 lakhs students. So 5 lakh students, they appeared in this particular CAT exam, CAT 2019. And if my percentile score, if my percentile score is 89, that means 89% of the people are, they have, 89% of the people have scored less than what I have. Okay, so let's say out of 1000, if my score is, let's say, 690, then 89%, that means 89% of the 5 lakhs people. What is the 89% of the 5 lakh? That many people have secured less than 690 marks. That's what interpretation is. Now, the quartile is what basically? So what is a quartile? The conceptually, the quartile is, so this is a maximum, this is a minimum, this is a maximum observation in the data. This is a minimum observation in the data. Now this is the boundary of quartile 1. Up to here, the observations can be said to be fall in quartile 1. So all those observations which are there up to this boundary, they can be said as they are the part of quartile 1. Now this is what, 25th percentile. This value is what, this boundary is 25th percentile. Now what is this quartile 2? Now quartile 2's range is this, the end of quartile 1, and this is the end of quartile. So this is the beginning of here, this is the beginning of quartile 2, and this is the end of quartile 2. Okay. Now here, at this end, the value of percentile is 15th percentile. As I said, my percentile is 89 and my score is 690 out of 100. Maybe somebody has secured 50 percentile and his score is, let's say, 490. So this is the value. So here, something could be there. I mean, some value could be there. This is a 75th percentile. And this is quartile 3. And this is maximum. This is quartile 4 and 100 percentile. Okay, clear with this? Now let me just quickly set one example and you'll at least get to know about this. Just a moment. Okay, so here I have a marks of the students. Again, let me just discuss with a simple example of this. Now, and I will follow your book for the calculation of the quartile. Today also I have to at least extend my session. Please excuse me for that because we have many topics and you are repetitively asking many questions. And I hope that I'm answering your questions. Yes. So these are the students. Okay, let me just show you the list of the students. Let me just at least put it like this way. Let me just select them first and arrange them as per the ascending order. Otherwise, you'll get confused with this data. So serial number A to Z. Okay. So these are the students. Okay. Now, so these are the marks. Okay. Let me just at least put it like this way. This is a dummy data. Actually, I have created this data. The hardly that matters. This is student number 1. So here we have the 50 students and their marks they have secured out of 100. Now the first student has secured 10, second 80, third student 70. The data is pretty random. Okay, data is pretty random. Now let's calculate the percentile. How to calculate the percentile? Okay, so this is a formula, but let me just show you that this is a percentile rank formula. Okay, so in Excel, this is a formula that we can apply. We can at least calculate the percentile based on the 100. So here we have selected entire array and we have selected, let me just show you how that is going to work for you. So this is a percentile rank. Select entire data of 50 students. So I have selected the marks of 50 students. Let me just log this array. So this way I just define the range first. They try to identify the maximum, the minimum marks out of this range. Now individual observation. Okay. Now this way percentile marks can be calculated. Okay. Let me just come back to the quartile, because now here if I take a look at the minimum mark, because I want to summarize the data and I'm trying to at least summarize this data using quartile and the percentile. Okay, now let me just tell you the minimum mark. The minimum mark the minimum mark is 2. I guess 2 is student 33 secured 2 marks out of 100. The maximum marks are equals to max. Let me just again select the entire range, hit the enter key. So this is a range, okay, 2 to 99. Now in 2 to 99, so here so it's like 2 is a minimum and here the 9 is maximum value. Now here I just want to find out the quartile 1. How many students may fall in quartile 1? That means how many students have secured more than 25 percentiles? How many students have secured 25 to 50 percentile? Okay. Now this kind of calculations are given in your book. Let me just give you the simple example of it, how you can calculate. It seems like very difficult, but believe me, it's very, very, very easy. Just pay attention. Don't do anything. Just pay attention. It's like very easy. These are the things that we have already discussed. Okay, here we need to stop. So this is a formula of, yes, this is a formula of a percentile. Okay, this is a formula of percentile to find out the percentile. Now, first of all, we need, because we have observed this particular value, minimum value, we need to know this one, this one, this one. What is this? We don't know. For that, we need to adopt this particular formula given in your textbook, page number 57, which is P by 100 multiplied by N. So here we can apply this formula. So what is P? So P is percentile value. So percentile value is 25th because Q1 ends at, quartile 1 ends at the 25th percentile. Now this is a mathematician already said, has already proven. You need not to at least, lost in those theories, except this, that this is the end of quartile 1. And at the end of quartile 1, percentile value can be 25th. Because quartile divide the entire distribution, entire range of observations into 4 halves. So definitely हर एक bucket में 25% 25 percentile के हिसाब से ही data points आएंगे, ठीक है? So this way percentile value is 25. N. How many students we do have? We have a data of 50 students. We have a data of 50 students. divided by 100. Tell me, what is this? What is I in this case? Tell me. Quickly, quickly. Please tell me quickly. 12.5. 12.5. Okay. Let's go to the data file. 12.5, which is that. Now we need to at least rearrange this data as per the ascending order or the descending order of the marks. Up to now, it's like based on the marks, let's arrange the data into ascending order. Now I is 12.5, right? 12.5. So 12.5 can be here after this. Okay. Let's calculate the quartile value. Is it 12.5? 25 multiplied by 50. Is it 12.5? Okay. So I equals to 12.5. So we need to look at the 12.5 observation. So observation which is slightly bigger than the 12.5, which is this. Which is this. Slightly bigger than the 12.5, which is this. Okay. Is it okay? Slightly bigger than 12.5. The observation which is slightly bigger than the 12.5. So this is this one is slightly bigger than the 12.5. Okay. Sorry, this observation. This is 12 marks and this is 14 marks. So it's between here. So it could be between here. Okay, this this is a percentile value actually. This is a percentile value. So they said that if this is ith, I mean that particular location we need to check. Okay, that particular location we need to check. Okay, so here let's say this is a 2.4. That means the value which is like very near, let's say very near to, let's say third place. That is this third place. Matlab this. Okay. So this is a percentile value. So here this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is 12.5. 12.5th position. Okay. This is 12.5th position. Now 12.5th position, which is nothing but the 13th position. 13th position. So let me just check it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14th. Okay. So 13th and the 14th. So this is like here in between these two observation, you can say that this can be the range. I mean, here the actual value. See, exact value of quartile it's like many times it's not possible, but you can at least identify the nearest value. Okay, so here it's like 17. You can say it's 17. Okay, and what is the percentile for this? It's 24.40. Is it okay? Is it okay? Oh, sorry, it's like the next percentage is like 26. N plus I position. Okay, sorry, it's N plus I position. Oh, sorry, I plus 1 position. So here, if this is a 2.5, they say that the whole number of 3.5 can be considered. That means 13th percentile is located there. Okay, at the third value. The same way here, we identified for the 25th percentile. So 25th percentile is this. So I plus 1th position, I plus 1th position can be 13.5th or 13th position, you can say. Let me just go back to my data and check it again. So this is first, this is second, this is first, second, third, fourth, fifth. This is the 13th position. Yes, I'm correct. So this value is what? 17. So quartile, so the first quartile ends at the 17 marks. So 2 to 17 marks, this is a range of, this is the area of quartile 1, area of quartile 1, 2 to 17 marks. Same way, let's find out the area of Q2, second quartile. So area of Q2, I equals to percentile. So at Q2 ends at the 15th percentile. So Q2 ends at the 15th percentile, 50th percentile. We have a 50 observations. We have a data of 50 students. Tell me this. It's 25th. And I plus 1th, matlab 26th position. We need to consider 26th position. Go back to the data. Let me just consider the 26th position. This is 26th position. This is 26th position. Let me just highlight this with different color. So I can say that this is a range of quartile 2. So quartile 2 ends at 60 marks. 60 marks. So quartile 2 area is 17 after 17th mark. मतलब 18 marks से start करके 60 marks. Okay? Got this? Yes or no? Yes or no? Now the same way you just calculate this. Now quartile 3. So that is a 75th percentile. Tell me this. Observation. 75 multiplied by 50 students we do have. Please calculate it fast. Many things are left. 37.5. That means 38.5, which is equivalent to 38th position. 38th position. 38th position. This is 38th position. Yes. This is 38th position. 85. 85. This is 85. Okay. So 60 marks to 85. This is the area of Q3. Okay. Tell me the area of Q1. Tell me the area of Q1. Person who has secured marks between 2 to 17. Tell me the area of Q2. Tell me the area of Q2. 18 to 60. Yes. Tell me the area of Q3. area of Q3, quartile 3, 61 to 85. And tell me the area of Q4. Okay. Tell me, what could be the percentile at the end of quartile 3? What could be the percentile at the end of quartile 3? What could be the percentile value at the end of quartile 3? End of quartile 3. Are end of quartile 3 I'm asking. Percentile, 75th percentile. 75th percentile would be there. 85 is the marks. Yes, correct. But I'm asking the percentile. Now you just observe this. Percentile we have separately calculated. Percentile we have separately calculated. Here at the end of quartile 1, you'll observe the figure is near to 25 percentile. At the end of quartile 2, the figure is very close to 50. At the end of quartile 3, the value is 75, 75th percentile. At the end of the last quartile, it's 50. Yes, Tejas, that could be there. Yes, Tejas. Tejas saying that it'll be say 86, not 85. It's okay. That much is okay. Now let me just tell you. These are the quartile values. You can find it out using now these are the quartile values which you can find it out using Excel formulas. But in Excel, let's say the formulas can be so accurate that actual quartile value you cannot, at least you may get a chance to observe, you may not get a chance to observe. These are the two possibilities. The actual quartile value may or may not be observed in the data, because that observation may be possible. या तो हो सकता है किसी ने उतने मार्क्स लिए ही नहीं है, हो सकता है कि उतने मार्क्स किसी के ना आए हो, जैसे कि यहाँ पे 19.75 मार्क्स, मे बी वो मार्क्स किसी को ना आए हो. ठीक है. सो क्वार्टाइल के बेसिस पे व्हाटएवर यू कैन कैलकुलेट, exact value cannot be possible, right? Now again, these are the nearest value. You can see note that the percentile may or may not be the one of the data values. Okay, so observe this line and follow it properly. Got this? Similarly, you can say it for the quartile. Okay. Can you understand what I'm trying to tell you is? Now, in order to decide the quartile value, if it is like 25th percentile, okay, this is the formula. If total numbers are like 8 there, in case of even numbers, in case of odd numbers, the calculation is different. Okay. Now, you just go through it. If you have any doubt, then you can at least text to me. But let me just discuss the very important aspect, because we have less amount of time. So what is a median? Median is nothing but this value is known as median. The end of quartile 2 and the 15th percentile, whatever the marks you observed for the person having 50th percentile, and whatever value you can observe for the end of quartile 2, that is your median value. Okay, let me just show you how median value can be calculated. Equals to median will be very near to the 50th percentile. Is 59.5. 60. Got this? Yes or no? Are you convinced with this? So situation is like this way. So this is a data distribution. This is a quartile 2 ending. Oh, sorry, this is a starting of quartile 2. This is a beginning of quartile 3. Quartile 1, quartile 2, quartile 3. Oh, this is a minimum value actually. And this is, let's say, a quartile 4. Okay. So whatever value you observe for minimum value, this is maximum value. Okay. Minimum value, this is the beginning of quartile 1. Here the quartile 1 ends. Here the quartile 2 ends. Here the quartile 3 ends. Likewise. Now, this particular region, okay. Now this is what? This is a median value. This is also known as 15th percentile. Okay. So this is before median value. This is after median value. This is called box. Any point which is falling, let's say, very far to this. Let's say most of the data points are falling this way, in this range. Many points, let's say data points are falling below the median. Many data points are falling above the median. But some points are falling very close to the maximum value. Let's say very less values are like this way. These are the outliers actually, which are falling very far from the normal spread, which are known as outlier. There are more techniques to detect the outlier, and whenever you observe any extreme values, there are certain ways, certain parameters to declare that as an outlier. We'll discuss in the regression session. Okay. So randomly you can't say that just because this is an extreme value, this is the biggest observation, that's why it's an outlier. No, it's not like that. There are certain ways to do it. Okay, so we'll discuss the box plot in the in the regression session. And in box plot, it's very much important to understand that, okay, this is an end of quartile 1, this is an end of quartile 2, this is an end of quartile 3, this is the end of quartile 4, and this quartile 2 ending is nothing but the median value. Okay, this knowledge is required. That's why I have discussed here. I hope you just got the clarity. One more thing I left: when you are dealing with the continuous data, how to find out the mean, median, mode, and all this. What is a way to find out the mean, median, mode, and other things? So when you are dealing with the, okay, when you have this kind of data, then which way you can at least find out the mean, median, mode, and all that? Do you have answer? This is a class interval. This is a frequency. This is a class interval. This is a frequency. This is a cumulative frequency. Tell me how to find out. You need to find out the midpoints. The interval is, this is like an unemployment rate of Canada in last 60 years. So if unemployment rate is, let's say, less, it's between 1 to 3% for 4 years out of 60, So midpoint is 1.5. Unemployment rate is between 1 to 3%. The midpoint is 1.5. When unemployment rate is 3 to 5, what is the midpoint? 4.5? Is it? It's 3.5. It's 6 here. Now in the bracket of 7 to 9% of unemployment rate, the midpoint is 8. Here midpoint is 10%. Here midpoint is 12%. So these are the unemployment rates, but these are the midpoints of the class intervals. Okay. Now how we need to at least, now again, we need to prepare one column, which is nothing but, let's denote this by so we need to find out the summation, multiplication of midpoints and frequency. This is a multiplication of midpoints and the frequency. Okay. So this is a midpoint, can be identified as MD, and this is MD. This is a notation for frequency, MD multiplied by F. Now summation of F, total frequency is 60 because we have a data of unemployment rate for the 60 years. Now summation of MD multiplied by F, 1 to how many intervals we do have? 1, 3, 6 intervals. What is the summation of this? 8 plus 48 plus 78, 152, 70, 60. It's okay, it's okay. Let me just at least, give me just at least 2-3 minutes. Okay. Find out this summation. What is the summation of 8 plus 48 plus 78 plus 152 plus 70 and 60? Tell me. Quick, 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 quick. Very quick. What is the total number of years? 60 years. 416 divided by 60. This is the average value. This is the average value. 416 divided by 60. 6.9 years. 6.9% unemployment rate. Okay. Now you can see that here they have given, at the end, they have given the same set of formulas for continuous data. Let me just at least show you where it is. Okay, this is the formula. And you can see that the same problem is given here. Okay, they find out, they just try to find out class midpoint first, multiplied by the respective frequencies. तो हर एक midpoint के साथ frequency का multiplication करके ये column बनाया, उसका summation किया. This way just try to find out mean. Okay, and this is a formula of median. Okay, go through it. If you have any doubt, next time we'll discuss this. Okay, here we close the session. Any doubt if you have, you can ask to me. If you have any